Hi guys, you're welcome to my channel. All right, today I'm going to walk you through the processes in which you pass through while undergoing any of these our online courses. Okay, I have number 1 to number 6, but the most essential apart from the first one is my number 6 here. Number 6 here is our electrical installation of building, domestic and industrial. All right. Now, before you embark in electrical career, you must understand what we call connectivity. Connectivity entails your ability to identify live and neutral and positive and negative. All right. So having gone through the safety that are associated to electrical installation as well, so you must understand that connection from negative to positive must be familiarized with before you go into electrical installation. All right. So I want to start the processes of this particular number 6. So we are going to expose you to reading of drawings, reading of layout drawing, floor plan drawings, a lot of them, such as this. This is a floor plan drawing. So we are going to understand how to read engineering drawings, such as installation of building drawings, different type of building drawings. So like here now, here is our distribution board arrangement. After your final connection in your distribution board, there is what we generate called a certificate of completion. So certificate of completion must be generated and pasted at the back of your distribution board. Okay, so this is the arrangement for you to generate that certificate of completion. So that is your load analysis as well. Okay, we also call it load analysis. So you must do this your load schedule and calculate the power, right? So that is the first stage, reading of drawings. Then the second stage now is for you to identify your load demand. This is also your load demand, okay? Load demand will enable you know the circuit and the load schedule. For instance, your lighting circuit, you must count each of the point must be assigned to a particular wattage. So you calculate them and determine how many wattage do we have total in this particular floor plan. Then divide them by the circuit to segregate the circuit. Okay, for instance, if I have 4 circuit total here in lighting point, so I will also keep that aside. I also determine my circuit of my ring circuit. Okay, that is the second step. So number of circuit must be ascertained. Then the wattage per each point must also be ascertained. Then the calculation that goes to a particular lighting system such as discharge lightings, and like I told you before, there is a factor set aside of 1.5 a factor to augment the starting current of discharge lightings and energy saving lightings, LED lightings, ceiling fans. These are the lighting system that you must augment by using 1.5, 1.8 factor to multiply them before you now determine their outgoing MCB, that is the protective device from your distribution board. All right, so you must do that. Then another step again is for you to understand your DB sizing, distribution board size, how to size your distribution board. For instance, this is my distribution board layout now. How many do I need? How many outgoing breakers do I need? So from your circuit calculation, you determine how many ways that you need. If you need D4, you need D6, or you need D8, 18 ways, 12 ways, and so on. That is how you determine them. Then from there, you do your calculation to identify the outgoing breakers, their sizes, their rating, and your circuit arrangement as well. Circuit arrangement is where you come to your floor plan. When you come to your floor plan, you now know how to arrange your circuit such that your living room, this is your living room, such that your living room and your dining shouldn't be combined in one circuit. Please take note that your circuit arrangement, while doing your carrying out your circuit arrangement, you should not combine dining and the sitting room, your living room, in one circuit. The reason is because when there is a blackout, when there is a power outage, a power failure in that particular outgoing circuit, then the dining and the living room will be blackout. So dining room should be assigned to a different circuit, then living room should also be assigned to a different circuit so that if blackout occur here, the dining can be illuminating some lightning down to the living room. Okay, so that is the reason why both of them must not be in the same circuit. That is for your circuit arrangement. Okay, so then another circuit arrangement, you should also know what we call side entering and back entering. You know, for instance, I have come to this particular room now. I have my 13 amps here. So I should use back entering to pass from here to the back of this place instead of wasting a pipe and a lot of cable going vertical and horizontal to another second room. So you can use back entering to pass from here to this other side. Okay, that is to minimize the use of resources and accessories. Okay, so we teach you how to do that. Then also teach you how to generate your bill of quantity. You know the size of the number of your materials you need for to carry out your installation. Then after that, we take a look at the earthing system. Each residential building or commercial building or industrial setup have a special earth requirement depending on the magnitude of the project. Okay, we now determine which type of earthing system do we need to um, initiate. Then after that, we also teach you the intake position. This is your earth arrangement, okay? This is how you do your earth arrangement. You have a diagram for it as well. Then another one again, like I said, is how to calculate your intake position. Oftentimes we discover that some of our technicians will buy distribution board with incomer breakers fitted inside the distribution board. That is not acceptable. It's not acceptable. That is not the right process. The right process is for you to do your circuit analysis, calculate your circuit, and identify each of the outgoing breaker, what is their requirement. You don't just buy circuit breaker, the outgoing with the distribution board because they will give you wrong breaker ratings. You have to write down your circuit and write down their breaker sizes and buy them according to your calculation. If I have, for instance, I have a lighting circuit of 15 point in one circuit. I also have another lighting circuit that is 10 point in one circuit. So they shouldn't be the same breaker. 15 point in one lighting circuit should use a different breaker size. Then 10 point of lighting circuit should also use a different size of circuit breaker setting because you must go according to their calculation. For instance, I assign 50 watt for each of my point. It's going to be 50 times 15 divided by 230 times 1.8 if I am using discharge lightings. Then if I am using 10, it's going to be 50 times 10 divided by 230. You now arrive at your breaker size. So you don't just pick your breaker sizes that was assigned and enclosed in your distribution board and use it to assign to any of your circuit. So you go by calculation. you know. We also have a permissible voltage drop that is assigned, that is stipulated by IET. We have a permissible voltage drop that we can work with. Lighting circuit voltage drop shouldn't drop more than 3% of the declared voltage. For instance, if we are using 230, then power circuit should not also drop more than 5% of 230 nominal voltage supply. Okay, so we must do our calculation and make sure we reflect all this. Then this our intake position, the voltage drop from your intake position shouldn't be more than 4% of your supply voltage. How do we know this? Is by carrying out our voltage drop calculation. If your service cable from your supply to the building is happen to be a considerable distance, so we carry out what we call voltage drop calculation to size our feeder and to size our supply sufficiently. Okay. Then another one again, our distribution board will teach you how to calculate the incomer.